If you're new to the HVAC industry or even a seasoned veteran, you may be wondering what exactly HVAC Building Controls, BAS, Building Automation Systems really is, or how it works. In this video, we're going to explore the 101s of HVAC controls, the heart of building automation. Controls are the devices in an electronic HVAC system that control various equipment with the help of communication of data between devices, hardware, and computer systems. While that may sound complicated and technical at first, rest assured, we're going to break down the basics of controls and their systems for you right now. Direct Digital Controls, or DDC, is the automation control of a device or devices using output signals generated from computer calculations based on an input signal and desired environmental criteria. DDC has been used in building automation systems since the 1970s. A DDC system is simply a collection of electronic controls and devices that share information to control internal environments. DDC is now installed in all new installations and can be used in existing buildings where mechanical, pneumatic systems are in place. These systems can be retrofitted and upgraded, supplying these controls. Let's look at a DDC system. We start with the controller, which is a device that processes input signal, calculates output signal necessary to control the internal environment using building equipment. Inputs are things like air temperature, humidity, CO2, airflow, or pressure signals that are sent from sensors. This sensor data represents the current condition of the space being controlled. The controller processes this sensor information and, based on desired environment criteria called set points, sends output signals to control equipment in order to meet these set points. The controller's internal computer is programmed to make decisions based on sensor inputs and desired set points, calculating the need for outputs. If a space is too hot, for example, the output of the controller will open a damper to let more cool air into a space. In order to control equipment such as dampers, air handlers, boilers, and chillers, DDC programs must take into account the time it takes for equipment to react to control signal and the signal levels. This is done using control loops, where there are mathematical calculations that consider the current sensor input, the desired environment, and the current control signal to determine the new control signal output to the equipment. Control loops have been used for many decades in many different types of industries. Besides these loops and their set points, there are other criteria used to control the internal environment of the space, such as whether or not the space is occupied and fire or equipment safety signals. For example, if the fire safety has been triggered, the damper then closes. If the room is not occupied and the temperature is below the unoccupied heating set point, then the room heating begins to warm. If the CO2 level is too high, then outside air is brought in. All DDC manufacturers allow technicians to specify desired set points for the controllers. Most vendors have incorporated pre-written programs into their controllers that cannot be changed, but some manufacturers, such as KMC Controls, allows more flexible ability by providing a way for technicians to easily modify pre-canned programs. Finally, one other key aspect of DDC controllers is the ability to communicate with one another and other computers. This allows the controller to use more data for better control of the equipment, and also for other computers to monitor performance or faults. And with modern platforms such as our IoT platform, KMC Commander, you can now visualize and command control of your system with your phone or tablet and connect other computers to your system to monitor and analyze its operation. The benefits of controls include an automated and more efficient way to control your building environment to desired levels compared to manually changing things daily. Protection of buildings and other content within real-time monitoring of heating, cooling, and humidity, saving you from burst pipes and broken equipment. Reduce operation costs by monitoring performance and setting optimal equipment runtimes. Increasing comfort and productivity by having properly conditioned air and correct exchanges of CO2, dust within a space. Safer environments with automated response for the fire and safety and emergencies. Less time spent maintaining the system, and early fault detection. Enable the use of analytics to further gain an additional 10 to 15% of energy savings with optimization. Controls are the foundation of the building automation system. With no control scheme in place, you typically have a thermostat that reads temperature and heats or cools the space based on that reading. It's either on or off. that leads to a lot of energy wasted, limited control, and reacting to problems rather than being proactive in maintaining equipment. With more than 5 million buildings in the United States alone with no controls in them, there's a great opportunity in the market for integration and for the end user to see the real benefit. For more information on building automation systems and how they can benefit you, check out other videos on our 101 series, or learn more about any of the solutions from the building geniuses at KMC. Visit us on the web at kmccontrols.com.